Energy is a special quantity that can be observed in our daily lives. Energy is defined as ability to do work. This concept was first developed by an English physicist named James Prescott Joule, which is why the unit of energy is joules, in honor of the physicist. Energy has two unique and important properties. First one is called the conservation of energy. It states that amount of energy is fixed and conserved within a system unless there is an external work done. Second property is that energy can be transferred into multiple forms. Most common forms of energy include kinetic energy, gravitational energy, and elastic energy. One way to understand the transferring of energy is making of French fries. First, potatoes are harvested from the farm. Then it is chopped and cooked into French fries, which finally ends up on your plate. Throughout the whole process, the potato still remained a potato. The only thing changed about the potato was the presentation. Similarly, during the transfer of energy, energy still remains an energy. The only thing changing is how it is stored.
Using these two fundamental properties of energy, we can solve complicated problems with relatively less work. Take this problem for example. Woo-hyun throws a baseball with speed of 13.5 meters per second. Assuming he released the ball 1.8 meters above the ground, what will be its speed when it strikes the ground? For this scenario, we will assign event 1 as when it leaves his hand, event 2 as when it strikes the ground. At event 1, the system will have some kinetic energy because of the velocity gained by Woo-hyun's hand and some gravitational energy gained by the height of the ball when it is released. At event 2, the gravitational energy is going to be 0 because the height of the ball is then 0. Conservation of energy states that amount of energy is fixed within the system. Therefore, all the gravitational force must have been transferred into kinetic energy. From this analysis, we can make a work energy equation for this scenario, which is gravitational energy 1 plus kinetic energy 1 equals kinetic energy 2. Using the energy formulas and height of and velocity of the ball, we can easily plug in numbers into the equation, isolate for v, and use calculator to figure out what the final velocity is, which turns out to be about 14.75 meters per second.